Hi, we are Team Codex and our study project is on VxWorks. So, starting with the introduction of VxWorks. What is VxWorks? VxWorks is a real-time operating system and it is used to build real-time application. Real-time applications are the applications where time is a major factor. The functional requirements for real-time operating system are the multitasking kernel, preemptive scheduling, fast interrupt response, and the intertask communication. So let's have a look at difference between OS, general purpose OS, and the real-time operating system. So these So the difference between real-time OS and the general purpose operating system can be explained with example of the ATM machine and the anti-braking system. For ATM machine, even if there is a delay of few seconds, it is fine. But in anti-braking system, time is a huge constraint. VxWorks RTOS is developed by the Wind River Systems USA. Tasks. So, task is any program which is in execution. So now moving on to the multitasking concept. Multitasking is where more than one task takes up the CPU execution time. Let's have a look at what context is. The task's context comes in picture during context switching. Here we store the state of the task. Now let's have a look at the available transition states of VxWorks. So here, apart from the pending and the ready states, we have two more states which are the delayed and the suspended states. So the delayed state is where the task is asleep for some duration and the suspended state is where the task is not available for execution. The task usually enters suspended state in error scenario. Now let's have a look at the scheduling mechanism offered by Wind kernel of VxWorks. So, task scheduling. The CPU will start with the preemptive priority scheduling. Each task here has priority between 0 to 255, with 0 being the highest priority. Now, what if there are two or more tasks having equal priority? In this case, the CPU goes for round robin scheduling. In round robin scheduling, the CPU execution time is fairly shared amongst all the equal priority tasks. Now let's understand the concept of priority inversion and priority inheritance. We'll begin with priority inversion. Priority inversion occurs when a high priority task is forced to wait for indefinite period of time for a low priority task to complete. So consider the figure. Here T1, T2, T3 are the tasks of high, medium and low priority respectively. So T3 has acquired some resources by taking its associated binary guard semaphore. T1 preempts T3 and competes for the resource by taking the same semaphore. It then gets blocked. If we could be assured that T1 would be blocked no longer than the time it normally takes T3 to finish with the resource, there would be no problem because the resource cannot be preempted. However, the low priority task is vulnerable to preemption by medium priority tasks like T2, which could inhibit T3 from relinquishing the resource. This condition could persist, blocking T1 for an indefinite period of time. So here basically what happens is that even though T1 was higher priority than T3, T1 will be executed after T3 is completed and when T3 will release its resources. So now let's understand the concept of priority inheritance. Priority inheritance basically solves the problem of priority inversion by elevating the priority of T3 to that of T1 during a time when the T1 is blocked on the semaphore. This will protect the task T3 and indirectly T1 from preemption by T2. So that was all about priority inheritance and priority inversion. And now let us move on to our next topic, which is intertask communication in VxWorks. So the facilities available for intertask communication in VxWorks are shared memory, semaphores, message queues and pipes, sockets and remote procedure calls, and signals. So now let's look into these concepts in detail. So starting with the concepts of semaphores. Semaphores are highly optimized and provide the fastest intertask communication mechanism in VxWorks. Wind kernel offers three types of semaphores. Binary semaphore. These are the fastest, most general purpose semaphores. Then we have mutex, mutual exclusion. This is a special type of binary semaphore. And then we have the counting semaphore, which is optimized for guarding multiple instances of resource. Moving on to the message message queues. The primary intertask communication mechanism within a CPU is via the message queues. In message queues, we can enqueue various number of messages of variable length and we can retrieve back the same using the dequeue process. So now let's move on to the concept of pipes. So pipes are nothing but the virtual devices by which the tasks communicate with each other through the I/O system. Pipes provide unstructured data exchange and facilitate synchronization amongst the tasks. So let's have a look at the basic differences between pipes and message queues. Pipes use I/O mechanism of VxWorks to transmit messages. Pipes return file descriptor which can be used in select system call when doing multiplexed I/O. The queuing of messages and tasks cannot be done in priority based order. So let's move on to our next concept, which is the interrupt service routine. So coming to interrupt handling, an interrupt is an asynchronous signal from hardware indicating the need for attention or a synchronous event in software indicating the need for change in execution. Interrupt holds the highest priority. So whenever an interrupt comes in, the CPU will save its current executing process state and it will handle the interrupt. Now let's have a look at how the interrupt is actually handled. So suppose this is a normal program which is executing. At this point an interrupt occurs. So here the CPU will save the processor state and it will start handling the interrupt. So after the interrupt is executed, the interrupt routine terminates and the processor state is restored. Once the processor state is restored, it will execute normally, that is, it will resume the execution. Now let us have a look at some of the features offered by the VxWorks. Uh, VxWorks offers separate interrupt stack to reduce the latency in servicing the interrupt. Also, interrupt handlers execute at a separate interrupt context level so that the interrupt handlers don't have to do context switch. Finally, coming to the conclusion, so these are the concepts of VxWorks which we covered as a part of our study project. We saw what is VxWorks. We saw tasks and task scheduling concepts, intertask communication which included shared memory, semaphore, message queues and pipes, sockets and RPC and signals. And finally we studied interrupt handling. Coming to the application part of VxWorks, VxWorks is used in networking field and is also used in the NASA Pathfinder. Thank you.